They will be going through Group 10's river and space gas analysis of the proposed portal frame structure. Starting with the main frame, the columns are 610 by 229 by 101 UB, and the rafters are 406 178 by 60 UB. Both selected from one steel span tables for a 30-metre span with a 6-degree roof pitch. The building has a width of 30 metres, an overall length of 28 metres, and an eave height of 10 metres. Bay spacing is set at 5.6 metres, resulting in 6 portal frames and 5 bays in total. Secondary framing will use the C224 girts at 1200mm centres and Z150-12 purlins with 1 rail bridging per span. A fascia purling FP23019 was incorporated to provide a clean eaves line and a straightforward connection for wall cladding. The mezzanine floor sits 4 metres above ground level and covers approximately 168 square metres. It's supported by 100 by 100 SHS posts and C250 joists, forming a stable intermediate platform. Slab is 400mm thick with an edge thickening of 850 deep by 450 wide to enhance load transfer and stiffness. It's offset slightly from the columns to allow for cladding clearance and footing detailing. In total, the design includes 11 windows, 2 steel access doors, and 2 roller doors, exceeding the client's minimum requirements for access, lighting, and ventilation. To sustainability brief, the roof incorporates 6 bridge ventilators spaced evenly for natural airflow, along with translucent roof strips across each bay to promote daylighting and reduce energy consumption. Overall, the Rivet model meets the client's objectives for functionality, accessibility, and energy efficiency while maintaining structural economy and compliance with Australian standards.
Following on from the Revit model, our portal frame structure was analysed using space gas, incorporating the load cases defined in AS 1170. This included dead, live, and wind loads, both internal and external, applied according to the site conditions for Wollongong, which is a Region A2, which can experience design wind speeds of up to 162 km per hour. Based on the preliminary member sizing and geometry from our Assignment 1 model, the structure demonstrated adequate performance under all governing load combinations. The analysis confirmed that the frame system remains stable, continuous, and capable of carrying applied design actions. All connections at the apex and eaves were modeled as fixed to allow for moment continuity through the rafter and column members, while the column bases were assumed to be pinned to represent realistic rotational movement at the footing interface. This assumption reflects common practice in portable frame design, where the base plates allow limited rotation and the majority of the moment resistance is carried through the rafter to column joints. Bending moment, shear force, and deflection diagrams produced in space gas confirm this behavior, showing zero moments at the base supports and peak bending moments at the haunch and apex regions, consistent with a pin-based rigid portal frame configuration. While the preliminary member sizes already satisfy design intent and serviceability criteria, further refinement will allow for a greater material efficiency and cost reduction without compromising safety or structural integrity. In conclusion, the proposed portal frame represents a robust, efficient, and well-integrated structural system that satisfies all load and performance requirements under AS 1170, achieving both structural reliability and design economy.